Rogni College of Engineering and Technology, aggregated with A+ grade by NAC, Department of Civil Engineering, C3402, Strength of Materials, Regulation 2021, J. Anand, Assistant Professor, Department of Civil Engineering. So again, going to see the topic torsion. So introduction. As a shaft is said to be torsion when equal and opposite of shear forces two ends of the shaft. The torque is equal to the product of the force applied and radius of the shaft. Due to the application of the force at the end, the shaft is subjected to a twisting moment. This causes the shear stress and shear strains in the material of the shaft. Next, so derivations of shear stress produced in a circular shaft subjected to torsion. Before the derivation of shear stress produced in a circular shaft, the following assumptions are to be made as. So this is the shaft considering the length is subjected to torque T, modulus of rigidity of the material, and tau is shear stress. Let O be the center of the shaft and D point on the surface of AB line shaft parallel to the axis of the shaft. So here, when the shaft is subjected to torque T, then the D is moved to D dash. If phi be the shear strain and theta be the angle of twist in the length. Here the shear strain is equal to distortion of the outer surface divided by length of the shaft. Then D dash is equal to L into pi. Strength or maximum torque in a circular solid shaft. The strength of the shaft means the maximum torque, minimum power the shaft can transmit. The maximum or transmitted circular shaft is obtained from the maximum shear stress induced at the outer surface of the solid shaft. That is tau into alpha into capital R. Let tau is equal to shear stress induced at the surface. The shaft due to torque T and or radius of the shaft, and small q is shear stress radius small r of the center. Therefore, the area of the A is equal to 2 pi r into small d into r. So consider a hollow circular shaft of the outer and inner radius R0 and R1 is subjected to a torque T. Take an elementary circular ring of thickness dr is distance r from the center is shown in bigger. dA is equal to 2 pi r d. The area of the elementary circular ring shear stress at the elementary ring is obtained from shear stress ratio. So this is the conditions. So turning force x distance of the ring from the axis. So this is the derivations. Tau by RO into 2 pi into small r power 4 divided by 4 RO and R1, and finally RO is equal to DO divided by 2, RA is equal to DI divided by 2. Substituting this in this condition, T is equal to pi by 16 into tau DO4 minus DI4 divided by DO. So this is the torque for hollow circular shaft. So this is the final conditions for the hollow circular shaft. So for solid circular shaft, so pi divided by 16 tau into area square, d square. Thank you.